Hello, everyone. We will get started with the content in about a minute or so just to let everyone get in here. Appreciate you guys being in here early. This one is really exciting. I think this is the largest webinar I've done in a long time as far as the number of registrants, and we're really stoked to provide this content. So before we get started, I am going to just post something in chat again that I had mentioned recently, that there is a 3-month DJI Terra license that's available for participating in this webinar. And what we ask you to do is fill out a short survey. It should take 2 minutes to do. You could do it like right now, or hopefully you don't miss anything important. But if you guys get that done, that'd be great. I've just posted it in the chat area within GoToWebinar. So if you click that link, it's a quick survey. You just provide your email. We'll send you the license via email after the event. So yeah, we'll get started in just a second. I'm going to take a sip of water and then we'll get going. All right. We're about a minute after the hour, and if there's others that are going to come in, I'm sure that they will be fine to miss the first bit. But again, thank you for being here. Today we're going to be talking about the Mavic 3 Multispectral and talking to Kyle Miller, who's joining us from DJI. He basically said if there's one thing he's excited to talk about, it's this product, it's this use case. And so for me, it's the opposite, that I don't have a ton of background in multispectral imaging, so I'm really excited that there's someone that can carry that weight for us. A few housekeeping things. First of all, this webinar is recorded. We will provide that recording to everyone that's registered or everyone that's here within 24 hours afterwards. So keep your eyes open for that. So if you do have to drop off, you'll still be able to see the content later. Obviously want to say thanks to DJI and to Kyle for making their time available for us to get this done. I think the drone industry could all use more content, especially coming straight from the manufacturer, so that you can bank on what's being said. So that's really awesome. I mentioned the DJI Terra thing. I put the survey in the chat, and I'll also remind this throughout this event that there is this survey to do, and then you'll get your 3 months free of DJI software. This webinar is interesting because we did it in collaboration with partners in the United Kingdom and Australia. So I want to say thank you to 𝐶𝐄𝐁𝐻𝐃 in Australia and Copters in the UK for making this webinar and the information provided go further. I think that when we just focus regionally, there's so many other regions in the world that don't get represented or don't get the same access to this information. So we're really excited that we were able to partner up with 2 other really strong drone resellers in this space to make sure that this information can impact more and also help out the understanding of DJI technology across the world. The last thing is, if you have questions, there is a question panel within your GoToWebinar dashboard. Put in your questions throughout the event. At the end, Kyle and I will go through Q&A. The only thing is I do have a hard stop at the top of the hour because I have to go catch a flight. So anything that doesn't get answered, we'll make sure to answer and send out via email to everyone that is here. So that is everything on the housekeeping front. Let's talk about the Mavic 3 Multispectral. Kyle, do you want to just say hello and talk a little bit about your background, not only in drones, but just in the ag space and remote sensing as well?
Sure. Once again, great to be on with you, Randall. We're probably going to make this a much more common occurrence. And yeah, since we did a webinar back in November, December, I'll keep this part brief. But my name is Kyle Miller. I'm on the solutions engineering team at DJI. I've been in the drone industry now for a little while, working past roles mainly at Drone Deploy, Ag Eagle, back there selling fixed-wing drones. But I'm actually from Eastern Iowa. My parents and my wife's parents raise corn and soybeans, and that's their main occupation. And we help out on the farm. And so getting into farming, I mean, we're getting into drones. That was back 10, 12 years ago, where you're building your own quads just for mapping purposes of farms. And ever since then, the passion of multispectral has been present. So excited for the Mavic 3 Multispectral, and really excited for this growing season.
Sounds good. And I'm Randall Warnas, your kind of host for this afternoon. I am the Executive Vice President at Enterprise UAS. We serve drone users across all sorts of use cases. And so I've been in the drone industry since 2014. Kyle and I met in 2016. And so we have a long-standing partnership, relationship, and understanding of each other. And we're just happy to be two guys sharing what we've learned over the years about drones with you. And like Kyle mentioned, this is not the last time that we'll be presenting things together. So just keep your eyes open for other events like this, where we'll maybe dive deeper into other products or other softwares. And hopefully you guys find this information useful. So today, like I said, we're going to be talking about the Mavic 3 Multispectral. This is like if Kyle had a robot as a child, this is what it would probably look like. I know that Kyle, you're quite passionate about it. So let's talk about like just the very basics of what you can expect when you pick up a Mavic 3 Multispectral.
Sure. So you're going to hear me compare where we're at now with the Mavic 3 Multispectral in a couple of different manners. One, comparative to previous generation, the Phantom 4 Multispectral. Two, comparing it to what we have on the market. And three, comparing it to what we were doing 2, 3, 5, 7 years ago with Multispectral. So just a quick overview. This is really the only solution that's out there on the market that's priced at, especially this affordable, that includes a high resolution visual camera capturing individual bands of light very accurately, as well as having RTK on board. That camera is on a 3-axis gimbal, all on a drone that can fly 40 minutes. That's just one integrated unit. There really isn't a product out there like that. A lot of other solutions are going to be costing tens of thousands and adopting other third-party payloads onto other drones. So this is, as far as just getting the best bang for the buck for multispectral, this has come a long ways.
And it's not just multispectral. I think that that's another key thing that we'll touch on throughout, is that even if you're doing surveying, RGB surveying of the land, this is a drone that's equipped and capable of doing that as well. So you're not stuck with just a multispectral payload up in the air, right? And that's a departure from what things were before.
Exactly. So this drone still, it's focused on mapping, but it's taking away from the Mavic 3 Enterprise's inspection capabilities and getting into vegetation management. So ultimately, you're choosing between the M3M and the M3E based off of inspection or vegetation, and every other aspect of mapping is going to be just the same.
Perfect. So let's talk a little bit about the drone itself. We're going to dive deeper into the payloads, but what, for those that aren't aware, what makes the Mavic 3 component of this special? What really are the features that make life easier than its predecessors or other technologies that are available?
Sure. So this slide, it's going to be hard not to compare to the previous version with the Phantom 4 Multispectral, but it's something that's very compact and portable. I mean, I've got the case right here, and you can throw this in the back of anywhere. And this is fitting 5 batteries, drone, smart controller. We'll get to what's in the box, but it's a very compact design. It's something that's flying 42-minute flight time. We're promoting somewhere around 30 with the Phantom. So we're getting greatly improved flight times. We're also improving the 4/3 inch sensor. So it's the same sensor that's on the Mavic 3 Enterprise. But then you're also getting the spectral side of it as well. So you have 4 other 5 megapixel that are going to be capturing red, green, near infrared, and red edge. And then there's a couple other differences you're going to get on this drone comparative to the other Mavic 3 Enterprise series. One of them being that it's a sunlight sensor instead of a beacon. And then it's using, just like the Mavic 3 Enterprise, the RTK module on board for geotagging imagery, as well as that O3 transmission. So you can fly that drone, to the other side of the field and not have to worry about it.
Something that we might talk about later, but the RTK module is a separate accessory, right? You basically have that port for adding RTK, but it doesn't come standard, correct?
Correct. So it's just going to be an add-on, but for multispectral work, and we will get in why, this has got to be about the easiest box to check when you are looking to purchase, because this $700 is going to go a long ways. We'll get to why.
Perfect. All right. So starting with the RGB side of the payload, because this is a mapping focused drone, even though you mentioned that there's the vegetation aspect that makes it multispectral. What is special about the RGB capture camera, and what can you assume you can, what can you create, or what kind of data can you get from this payload?
Sure, great question. So if we look at the Phantom 4 multispectral payload, that was just a small sensor, 2 megapixels. Now we're going up to even bigger than what the standard Phantom have at the 1-inch sensor. Now we're at a 4/3 inch sensor, 20 megapixels. And what that's going to unlock is we always had to battle between spatial resolution and spectral accuracy. And now we're going to be able to combine the two by maintaining that 4/3 sensor. You're going to get really high GSD on these maps, as well as really clean imagery, because it's a mechanical shutter. It's capturing every 0.7 seconds. And so you're going to have really good imagery to run machine learning on for analysis for visual, but then you're not sacrificing the multispectral side. So since it's the same camera that we made for the M3E for mapping, that thing is a mapping machine.
And two of the specs that are shown here that I think could be dug into a little deeper is the mechanical shutter component. How important do you think it is to have a drone with a mechanical shutter versus a rolling shutter?
Sure, we talk about it quite a bit in the survey world, maybe less in the agricultural world, but it's just as important in the ag world. When a lot of the analysis we're doing, we're flying over even conventional fields or the plots, that microplots that we're looking at. Most of that data is sub-inch accurate. And so if you're utilizing a rolling shutter, you're adding distortion in there, and that can be a cause of miscounting a couple plants, coming up with the wrong analysis, and then you have the wrong insights. And so mechanical shutter, higher levels of accuracy. And then the minimum photo interval, I know you're getting there. That's greatly improved. That's basically allowing you to map much lower. So if you're looking at high GSD for counting plants or understanding weeds, we're still flying at that low altitude at 30 miles an hour because we're capturing at 0.7 seconds. And so we're able to cover much more ground and still capturing much higher GSD.
Kyle, in the past, you've been able to read my mind, but that wasn't my other one. The other one was the ground control point free mapping. Is it? And this is like ignorance. This is me just not knowing. But if you added ground control points to this sort of work, is it going to improve on what the RTK module can do? Like, can you get even better if you did use ground control points, or is that you wouldn't use them because this is going to get you all that you need?
Another good question. Drone Deploy is actually releasing an article in the next week or two, and we did a collaboration with them on the Mavic 3 Enterprise series. We found that ground control points can and typically do add a little bit more accuracy, but it's very marginal for the amount of work that's added. But with RTK on board, now all you have to do is lay out a couple checkpoints and you're good to measure against the accuracy. So it takes away a lot of the workload that you'd have in the field, as well as laying ground control points in the middle of a field in 9-foot tall corn, really hard to do in the center. So it just removes a lot of the work.
For sure. Okay. Yeah. And again, that was just because I know that ground control points in the past have been extremely almost necessary to get high accuracy. And so I didn't know if it still made that improvement. So I appreciate the answer on that one. Now let's go to what makes it multispectral. And one area that I think is also important, well, two areas that I think is important to cover. One, why there's no blue. And second is that someone had messaged me about the red edge of the Phantom 4 multispectral being not so great. And if you have any background on that or opinion on that, and if this is either better or if that might have been overstated, because I couldn't answer that.
Sure. So yeah, there's a decent amount to unbunk here. I'm not surprised with the Phantom 4 multispectral a bit. The one upgrade, massive upgrade you're going to see, the Phantom 4 multispectral had 2 megapixel imagery. Each camera is 5 megapixels. So you're looking at 2.5 times the GSD, so a bit more clarity in there. You're also going to notice we are capturing 4 bands in there, green, red edge, near infrared. You can see which bands of light we're going after. The Phantom 4 multispectral was plus or minus 32 nanometers. We're tightening that up quite a bit. So it's becoming much closer to some of the other industry standards we're seeing with Mica Sense or the Sequoia, things like that. So the accuracy of the bands is greater. the GSD is also greater. We did have to drop the blue band, like you mentioned. There are some analysis that the blue band does help with. There's some wheat analysis, but overall, we found most people running NDVI or enhanced NDVI or OSAVI. Most of those indices are using red, green, near infrared, or red edge bands. And what we can do by sacrificing the weight and size of a blue band, we can still maintain the large visual sensor, which is so important to get spatial and spectral accuracy and resolution. So there's a sacrifice to be made, and we kind of pulled the plug on the sensor, the band that we found the least valuable.
Perfect. And here's another question. When you're doing a survey, capturing survey data, you can tell the drone to only capture RGB and not capture in multispectral. And I would assume that there's the possibility of the inverse, where you're only capturing from those 4 multispectral cameras and not capturing the heavier data intensive RGB images from a 20 megapixel camera. Can you capture all at the same time, so you're basically able to do the overlap of the map to the multispectral data?
Yes, another good question. So you can turn on either one or the other or both. Typically, we're going to, if we're running vegetation and we're running the multispectral, we will leave the visual camera on. But there are plenty of reasons in the enterprise space where they're using it for just a mapping drone, where they don't want to capture 30 gigabytes of multispectral data. You can just shut those bands off.
Perfect. Thank you for that. So this is a comparison slide to the Phantom 4 multispectral, and you said you were going to look at historical data. You touched a little bit on the accuracy improvements, but what else can we kind of expect from this jump from the Phantom 4 multispectral to the Mavic 3 multispectral?
Yeah, I mean, the biggest one here is the visual band. Like, we were stacking all 6 sensors at 2 megapixels, so we were getting the right spatial or spectral accuracy and spectral resolution, not even, but by being able to keep that 4/3 sensor on there, that's the largest difference you're going to see. It's not having to sacrifice the spatial side.
Okay, perfect. I think we touched on most of the other things. I'm just trying to make sure. I think we're all right, but if anyone has any questions about, there's specific questions that go from Phantom 4 to the Mavic 3. If you have those, throw them in the question section. But I think we mostly covered what the payload differences are. The airframe differences are vast, but that's like a different conversation as a whole. Smaller footprint, obviously, longer flight time. So you mentioned the sunlight sensor being replacing the beacon. Do you want to talk about why this is important, how this is used for those that are doing ag work? Because this is unusual for other drones in our space.
Yeah, I mean, you're really only utilizing a sunlight sensor for multispectral work, which, like you said, we had over 800 registrants. It's quite amazing to see the attendees for what I guess I would consider more of a niche industry, niche product, but it's one that I'm very passionate about. And so getting back into the sunlight sensor, we take the beacon out of the drone of a Mavic 3 Enterprise or a Mavic 3 Thermal, which is most commonly used. But here, what we have is off the back end of the drone, you can kind of see that it's white there, but it's almost see-through. There's a sensor behind that or below that that's an ambient light sensor. So while you're flying, if the sunlight changes, whether it's from day to day and you're trying to go out and fly that same field every day and every week and trying to do some trend analysis, or even during the flight, if you had a large amount of differentiation on cloud cover, the camera is going to automatically adjust that so that your NDVI values aren't all askew depending on what the ambient light was above. So if you're looking for more accurate data with multispectral, you really need to have something reading what the ambient outdoor light is.
So let's imagine that we're talking to this audience that is here right now of folks that have some understanding of drone data capture, but maybe not multispectral data capture, or they're used to taking pictures with drones, but they've never really done photogrammetry and things like that. My question is, pertaining to the sunlight sensor, is this part of the 𝐂𝐄𝐿 data that's stored onto each image, or is this just the drone knows what to do to adjust the images, but you would never actually see the data that's presented by the sunlight sensor? Does that question make sense?
Yes, it does. And the data is logged. So if you need to do any sort of adjustments that you can. Yeah.
Okay.
And another thing to add on there, just because sunlight sensor, we're talking so much about accuracy. Common question, reflectance panels. We can utilize reflectance panels for a bit higher level of accuracy. Essentially what that is it's a target on the ground at a specific band of light, and you can calibrate your multispectral camera for it. Now, DJI, we're not going to manufacture them, unfortunately, but if you have a calibration panel or make one, you can implement there too. So sunlight sensor and reflective calibration panel, you're going to have some really accurate results.
Awesome. I guess if anyone has questions about those reflectance panels, because I don't know anything about them, maybe Kyle has some suggestions of where you could get them, or if anyone does have suggestions, we might learn something together. But thanks for sharing that, Kyle. This is, I guess, terrain following is not a new concept, but I think that it varies as far as the reliability and trust that you can put into terrain following. Where do we stand with the Mavic 3 series of drones for terrain following, and how is it helpful when you're looking at crops that are most likely going to be pretty flat surfaces?
Yeah, that's a good question. While the crops may be flat surfaces, which ultimately is going to help with the terrain following, we do live in some areas that are hilly terrain. I'm close enough to the Mississippi River where we get a couple 100 feet of elevation change in some of our fields. Not most of them. We've got a decent amount of river bottom stuff, but the importance is there. So we need to make sure the drone stays somewhat the same height over the canopy so that we're getting the same side lap and front lap settings so that when we go to process the data, we get a good output, as well as the GSD, so the resolution of the map stays the same, because if you have variable there, you can run into some problems when you start to do analysis on counting plants and things like that. And yeah, it's terrain following, as in the previous, has been really difficult to do. You have to fly the field beforehand to load in a base map, whereas now we just unlock the obstacle avoidance sensors. It's working really, really well from the testing that I've had done on vegetation. And now we just unlocked a beta firmware. Actually, I think it's out now to go down to 30 meters. So guys that are looking to do 150, 160 foot flights, get a little bit higher GSD, we're going to be able to get even lower. And I know some third-party apps that can bump even lower if you're looking to utilize the obstacle avoidance for terrain following.
So you, Kyle Miller, or you representing folks that are doing these sorts of multispectral surveys, would you have terrain following on every time, most of the time? Is there a sort of decision that you need to make before you do that flight to determine whether you would turn it on or off?
I'm going to turn it on every time. So okay. Previous, I wouldn't necessarily worry about it on somewhat flat terrain, but now it's just a toggle, and the testing that I've done has been rock solid. And so even if it's only changing 5-10 feet, it's probably not going to make a difference on stitching, but I'm just going to toggle it on, and it does a pretty good job.
Perfect. So it's not like there's any secret sauce to understanding the variance of using it. You just use it and set it and forget it type thing with the terrain follow.
It's becoming that way finally.
Beautiful. All right, so this is kind of more for the drone itself, but the RC that comes with all of the Mavic 3 Enterprise series of drones is better than what we've used in the past. And just what kind of features, if those people that are moving from, say, a Phantom or something else into the Mavic 3 series, can they expect from the Enterprise version of the controller?
Yeah, so the Enterprise controller has, I think it's 2000 nits peak nit brightness. So you're gonna have a really bright screen out there, something that's most likely brighter than any iPhone or iPad. You're also not gonna have nearly as many overheating problems as some of those devices are, especially when you're in the summer in the Midwest, you're getting a lot of heat. You're also not getting phone calls on that device, which makes a big difference, or notifications. It's charges via USB-C, super fast. On the very bottom of the controller, it's got mini HDMI out. So if you are looking to present to an audience, it's just hardwired in, super easy. And it's got DJI O3 Enterprise, so the typical range that we're looking at. Honestly, nothing too special to talk about here other than if you include the price of what the Phantom 4 multispectral cost, the controller, and then buying an iPad for the drone, this saves a lot of money.
The only question that I would have is that when you're capturing multispectral data, because obviously this picture it doesn't have anything on the screen. We don't have anywhere in this presentation that we're showing like the app itself and where you would make these changes. But are you basically, when you said you can capture just multispectral or just RGB data or both, is that always going to be, is it pretty present where you would choose to capture that data? And is it like split screen when you're capturing both?
Yeah, so you can do the side-by-side mode, much like thermal for people that are flying thermal payloads. And that's going to be a live NDVI comparing near infrared in the red bands as well as just the visual. And then also you can turn on the camera settings, so just like normal camera settings in the DJI Pilot 2 app. You can change what bands that you're going to be capturing. And then if you're planning missions within Pilot 2, you'll just select if you want to capture, capture multispectral or capture multispectral plus visual or just visual. So it's pretty obvious whether you're planning a mission or you're flying where to turn things on and off.
Perfect. And I don't know which is worse, your phone ringing or housekeeping coming to take me out of my room, but I have late checkout. I'm not doing anything wrong. Anyway, thanks for that, Kyle.
No worries.
And then I think this is the last part on the drone itself, and we talked about this when we did the the Mavic 3 Enterprise drone discussion. But what has changed from, let's say, previous versions of the Mavic or previous versions of the Phantom when it comes to obstacle avoidance and data security? I think that it's probably less important when we're talking about looking at traditional crops, and when we're talking about data of crops, it's probably less sensitive than maybe others. But what can we learn as far as what improvements DJI has made on the Mavic 3?
Yeah, sure. With the Mavic 3 compared to the Phantom 4 multispectral, we're going to have obstacle avoidance on all sides of the drone rather than just whatever's on the front. I mean, if we look at where we're flying with ag, it's pretty common if we're flying super low that you're coming up against a tree line at the edge of the field. So making sure that you see that tree line, or if you're flying around bins or machine sheds, other vehicles, things like that. Also, what you found is guys will take it directly out of their shop, turn it on the cement pad that's just outside and launch. That used to be a problem, still is a problem with some drones that are not DJI, but with a lot of compass calibrations and IMU calibrations and things like that, the safety aspect with the Mavic 3 Enterprise and the Mavic 3 Multispectral to just set it and forget it and trust that the drone's calibrated correctly, we've come a long way.
Okay, and then for ag inspections with obstacle avoidance, do you turn that off most of the time unless you have a tree line or something that you're considering, or
keep it on?
Keep it on.
Just keep it on, just in case.
Okay, yeah. Perfect. All right, so DJI is obviously the leader in third-party collaborations with software companies that are building onto their platform, and we can mention where the Mavic 3 Multispectral is what it's compatible with today. But I also wanted to touch on specifically DJI Terra, but also this smart farm thing. What can you say about the Mavic 3 multispectral data being enhanced or processed and used with the softwares that are available out in the market?
Yes, so Pilot 2, that's one that I'm really going to tout and recommend. I mean, there really aren't any other alternatives, but Pilot 2 being able to go out and capture the right data with your multispectral drone, it's going to have all the different mission settings, whether it's mapping, whether you just need to do waypoints, or if you're doing linear for enterprise, if you're doing pipeline inspections from vegetation encroachment management, being able to do linear flights. Pilot 2 is going to be a great software to be able to plan missions. Terra and Smart Farm are there to be able to process and analyze the data. So DJI Terra is going to be about the best bang for your buck for processing large multispectral data sets. It's also nice that since we manufacture the drone, we understand pretty well on how to process with photogrammetry the data sets, but you're going to see a lot of different tools like the Pix4D Smart tool and Pix4D Fields being able to process the data set as well. And then Smart Farm, that's going to be for some light analysis, which we'll get into on the use case side, as well as some fleet management. And you're also going to have any sort of agris management there too. So if you're looking to take data from the multispectral, process through Terra, and then kick it out to the agris for the application, you can run that prescription directly through Smart Farm.
Okay, and Smart Farm before had an asterisk on it that said like available in Q2 or something like that of 2023. Is that available now, or do you have a date of that release? Because not everyone, most likely, most people have not heard of Smart Farm before.
Yeah, it's a product that we haven't promoted very much, but see it quite a bit more this growing season. We'll probably do a specific blog post or publish something on Smart Farm before the growing season, but it's mainly there to be the analysis piece after Terra, as well as just kind of maintaining your drone fleet.
Okay, perfect. And I have to take a minute to say that in the promotion of this webinar, we did talk that DJI offered up a great number of 3-month licenses of Terra for those that participate in this webinar. So if you would like to use DJI Terra, or if you would just like to provide us feedback, because we love to have that, I just put in the chat that link to a SurveyMonkey survey. It takes 2 minutes. If you fill that out, you're going to be submitting your email. Through that email, you'll be sent the license for DJI Terra for 3 months. It's included with your purchase for 3 months, but this is just for you to try it maybe with your other DJI platforms that are compatible, that you can see what it can do. So take advantage of that. And like I said, even if you're not 100% sure that you'll use it, ideally that's why you're doing it, but the feedback is really appreciated, just so that we understand who you are, what you're doing, what drones you're flying. That helps us know like how we present information. It helps us know the people that are joining these webinars. So thank you. Like I said, links in the chat. If you can click on that, still pay attention to the content, but if you fill that out later, that'd be awesome. Okay, so now it's like the entirety of the rest of the presentation is so deep in learning about what is multispectral and how it's used in specific use cases. And I may have those like junior questions that maybe for me to have full understanding, or to just kind of to catch up to speed. I might have those questions, but this is like all you. So Kyle, what is multispectral and how does it work?
Sure. So let's start from the left to the right, and we're just going to do photos to make it easier. So on the left-hand side, we have the entire electromagnetic spectrum. That's basically everything out there. It's the visible spectrum of light that we can see. Colors, very small part of that electromagnetic spectrum, but when you zoom in, you can see it's typically between 400 and 700 nanometers. That's the distance, the band of light. Blue or purples being on the low end, reds being on the high end. When you get above that, that's into the near infrared. And then if you keep pushing, that's where you get into like thermal cameras. What we've noticed over the past decades of research is that within the visual bands of light, it is very hard to tell the difference between healthy and unhealthy vegetation. So between the blue and the green and the red bands of light, there's some differentiation, but it really takes the plant nearly dying, turning yellow, before we can actually see it with our naked eyes, that stress that's hitting the plant. But when we look at bands of light beyond what our eyes can see, beyond red into the near infrared, the differentiation between healthy and unhealthy just explodes. And so we're able to see when plants start stressing before the naked eye can even see it. And then what we're doing then is, can we make a management decision to save that yield potential that's out there? You can see on the right-hand side as well why we would need a multispectral camera. So on the bottom side of that graph, I apologize, it's a little bit small there, but you're seeing a 3-channel camera. 3-channel camera, just like on any smartphone that's out there, it's capturing red, blue, and green bands of light, and it's trying to capture all of those bands of light within those colored channels. So it's not being very accurate, but it's creating a very pretty picture. Multispectral, the other way. We're focusing on one band of light as accurate as possible. So if you look at what a multispectral camera is there, we are getting high reflectivity within those bands of light, and then it drops right back down. But we're very accurately picking out blue, well, red, green, near infrared, and red edge, rather than trying to understand the whole spectrum and being very messy at what band of light we're looking at. Next slide.
Kyle, one second. Before drones, were growers using multispectral cameras in another way as a traditional method, or was it using your eyes to see where you needed to address drought stress or insects or something like that?
Growers really weren't, researchers were, but a lot of that was, back in the 70s and 80s, they were putting up near infrared sensors, but that was on Landsat. So you're looking at terrible resolution, but it costs a lot to manufacture high resolution near infrared sensors. So it really had, the actual use on the farm hasn't taken off till probably the late 2000s with manned imagery, early 2000s, and then satellite data.
And then thus far, what have you seen as far as like adoption and efficiency or crop yield improvements by using drones? Is there any data that's out there that is more concrete of why and how, what is the benefit of using this technology?
That's what the next slides are going to be for. With ag, it is much more difficult, like the use case slides in entirety. Yeah. Ag is difficult because 50% of the time that I'm flying conventional crops and trying to do crop scouting, I don't learn anything. Like the problem areas of the field, I knew that's where the problem areas were because historically that's where they always are because of the soil type or whatever that is. But 50 or even 20 to 30% of the time, if we learn something, we probably can make a management decision that will pay off the drone 2, 3, 5, 10-fold. So it's not every time you go out there ROI that we're talking about with oil and gas and construction, but a lot of the values is can we find problems and fix them?
Gotcha. And is the multispectral data flown usually like mid-season, in the planting season, in the harvesting season? Like how long is the season that you would use multispectral data throughout the growing year?
Man, I shouldn't say it was one that Dronefly had created, but they have a really good representation of when to fly throughout the entire growing season. So we're going to be flying now and just using the visual camera to do any sort of topography and elevation change. We might be doing some subsurface irrigation, or not subsurface, we're doing some subsurface drainage. And if we're going to be doing any sort of tile work in our area, we might need elevation maps. We're flying early to understand with corn and soybeans to understand emergence. We're also flying it before putting on any sort of fertilizer, so side dressing or top dressing. We're also flying 2 or 3 times throughout July and August, mainly July, to stay ahead of any sort of disease and understanding if and when we need to apply fungicide. So the biggest times to fly in Iowa for corn and soybeans specifically is going to be typically the 1st of April, getting topography stuff all the way towards harvest and getting drainage stuff after harvest even.
So maybe one thing we'll follow up on is trying to locate that drone deploy thing, and when we send out either answers to the Q&A or recording or something, we could try to attach that to it. So I'll try to remember that. So what are we looking at here?
Yeah, so we just talked about what a camera looks like when we're capturing bands of light very accurately, but only individual bands of light like captured. We're not capturing all 3 within one image, we're capturing them individually. So each image comes back as a grayscale image, very accurate image, but we don't know really what we're looking at. It's just kind of gray, some parts are darker, some parts are lighter. You can see just a visual camera, but we'll take these individual bands and we will do a calculation on them to make, and if you want to go to the next slide, we'll do a calculation on these bands to make a map you may have seen before, a plant health map. So if you've ever heard of NDVI before, or a plant health map, it's usually based off of NDVI. All it is a calculation on the near infrared bands of light and the red bands of light. So here's a tomato plant. If you see the near infrared band image, the red band, we're subtracting the values, the reflectivity values, divided by the near infrared plus the red, a little bit confusing. But when you run it through, what will come back is a scale from -1 to 1. Typically 0 on that scale is no vegetation. Anything below that can be like water and different surfaces, but we're focusing on 0 to 1. The higher the number, the more plant biomass, the more vegetation is there. And so you can see on this tomato plant where the most vegetation is, where we're seeing the most dense. So we're taking the individual bands, converting them into a plant health map, but you don't have to worry about it.
So when you convert this, are you comparing plant to plant to know like where there are issues within your plot of land, or are you looking at the plant and comparing it to itself or a known species to let it know whether it's healthy or not?
Man, yeah, it all depends on what type of analysis you're doing. If you're doing trend analysis over time, you're comparing it to what that plant was a week ago within that plot. You could be comparing it to another plot for plot analysis to understand which plot is healthier. Yeah, it can be any sort of which way that you want.
Okay, and does Terra/Smart Farm / Pix4D or Drone Deploy help with that analysis?
Exactly. So we're teaching all of this, but you don't have to worry about it. We do this plant health analysis when you upload the imagery or when you load it into Terra and process it. All you have to do is hit a button and then it'll just turn on NDVI. But we're just trying to tell you the basics of what's happening. Exactly. Perfect. So there's a bunch of different, you can make up that calculation on these bands of light on however you want. The most common that we found is NDVI. That really correlates well to plant health. Whatever that reflectivity value is, if it's higher, it's usually a better plant. If it's lower, it's a worse plant or a stressing plant. But there are other indices that you can utilize depending on the time of the growing season. That gets pretty deep though. It might be hard to do with the webinar timeframe we have.
Perfect, but these are things to note, and these are also indices that are available through software, correct?
Through Terra, yep, or through Pix4D Fields or whatever.
Okay. Great. So let's start talking about use cases. And again, like this is stuff that you know through and through. So guide us through the different ways that this type of data is helping farmers. So I guess we'll start with research plots.
Yeah, so if we're thinking about how the Mavic 3 Multispectral has improved over other platforms out there, with research plots, the accuracy is so important. So it gets back into a $700 module. If you're able to get that data, you have plots that are right next to each other, and those plots are already they've already been mapped out with sub-inch accuracy. So if you want that data to align every time you fly over it with near inch accuracy so that you're getting the same results and you can analyze the same plot, being able to implement RTK on board is going to be very important. And then by implementing multispectral and the accuracy there, if you have the location of the plot, you can then very easily get the average reflectivity score of that entire plot. And so if you have 1,000 plots out there, you fly over it with the Mavic 3 Multispectral with the RTK module on it, you can very quickly get a grading score for all of those plots nearly instantly. It's based off of plant reflectivity. So take that, you can also include some, if you've done some soil testing and some tissue analysis, you include that with some of your other research plots. But if you're looking for the best bang for the buck of just being able to cover a field day, week in, week out, and understand trend analysis, a $4,000 drone to get sub-inch data within a couple minutes over a plot, it's going to be really hard to beat.
Two quick questions. One, when you flied this data or you put it into the software, did you tell the software what plants you were flying, or does it know? And the second question is, who does research plots? Is it like universities? Do growers do it? Is it seed companies that do it? Where would this exist in the real world?
It can exist. So two different questions there. It can exist in a bunch of different aspects of the ag space. So a lot of farmers and a lot of growers, they may have their own plots. Seed dealers are going to have their own plots. They're typically just not micro plots. But you still want a score back from them, and those maps are going to need to be accurate. Now, what you're seeing here with micro plots, that is typically going to be a seed or a chemical company or a college institution that's running different tests.
Gotcha.
But plots can be all over the industry. But back to, it doesn't know what crop you're flying over, but you are getting a reflectivity value, and you can compare that, like you said, against itself at a later time or against other plants within the map. But that's where we're going to be getting into third-party companies with a little bit in a couple of different slides here that can do the actual analysis of differentiation between corn and soybean plants and things like that.
Great. So now next we're talking about orchards.
Yes. Didn't want to leave out, just because I talk about row crops all the time, didn't want to leave out orchards, vineyards, specialty crops as well. And this actually shows one of the features that we're releasing with Smart Farm. So being able to fly over it very quickly. And then when you load that into Smart Farm, you're going to be able to get an actual bubble over each individual tree. And then once again, get a score on that tree. So you can see at the very north end, we're getting back a very poor size and reflectivity score so that we can understand in those areas, we probably need to check on those trees the most.
Okay. Next we have herbicide application.
Yes, and this is one that I actually presented with Agrimo at Airworks. So last year, it was a little bit difficult for me to get a T30, so it was a bit last minute. This is a soy, you can see on the left-hand side, a soybean field with a corn plant, 2 corn plants in it. We are a corn-soybean rotation, so every other year we'll come in with either crop, and it's pretty common to have the previous year's crop in that field. It's not that big of a deal with soybeans because the corn is going to be growing so tall, it takes over, and the soybeans then wouldn't get any sort of sunlight, and they'd stay small and not take much yield away. But with corn, both the cleanliness of the field, farmers like their fields looking clean, plus that corn plant is taking away from yield potential of all the soybean plants around it. It's taking up nutrients, it's taking up water, and so it is essentially a weed because we're not harvesting corn there. So we're able to fly over it. This is with the Phantom 4 Multispectral. I had to fly the 70 acres. I think it took me over 3 batteries because, once again, I had to get high resolution 2 megapixel cameras on the Phantom 4 Multispectral. We made it work, but it was not scalable. But now that we have a drone that has 20 megapixels and then 5 megapixels on the multispectral side, we're going to be able to do this analysis at 200 feet at 30 mile an hour and crank through some fields. Anyways, sorry, go ahead, Randall.
Is what's being discovered that there is a corn plant present, or that there's plants around the corn plant that are being stressed or not as healthy because the corn plant is there? What is the camera seeing?
So you could potentially see a reflectivity score hit on the soybean plants around it, but most likely we're just looking at the visual camera and we see, based off of machine learning, we've trained it to say that's a weed, that's a corn plant in a soybean field. And so it's basically just looking for the corn plants.
Gotcha. Okay, so this is not multispectral data that is necessarily being used here.
Correct. You can do this analysis with multispectral or with spatial, but you need one of the two. You need either accurate multispectral or high resolution and accurate spatial. And we're getting both rather than just one with the Phantom line. But what we're able to do, sorry, go ahead.
No, you go ahead.
But what we're able to do is fly over it very quickly now. And then with Agrimo, they're able to analyze, understand where all of the individual corn plants are, kick out a prescription map, and then we actually flew it with the T30 and sprayed just those corn plants within the soybean field. So we saved on herbicide costs. I think there's a slide or two in there on the next slide showing what the yield difference that we were able to get. So we took a T30. You can see there's a couple different aspects here, but it's yield hit of the corn plant being in there. It's also, if you were to spray that field, you would have to drive through it. And typically driving through a field, you're taking a 1 bushel per acre hit anyway, anytime you're driving through it, because you're mashing down plants. So you have to take that into account. You also have to take into account how much it costs to spray using a giant machine compared to an Agris. And so overall, we were able to profit about, or save on yield potential over $3,000 by doing it this way with an Agris compared to a ground rig. But either way, we're able to identify the weeds and spray just those weeds.
Really cool stuff. All right, so what are we looking at here? Because I don't.
Yeah, there's another, if you want to go ahead and hit play, I do want to show, so the analysis there with Agramo, we flew, we upload, we process the data, they run the analysis, we kick it back, and within the next day or two, we're able to run. But you're starting to see more tools at the field's edge, such as the Pix4D Smart tool, where you fly over a field and you could just touch on some of the corn plants. You could just tap on them and then hit analyze, and it would analyze the entire field for all of those volunteer corn plants and then kick you a prescription. And you can actually edit that. If the analysis didn't come out well, you can say, hey, you missed that plant, that plant, that plant, reanalyze, and it'll correct and make a more accurate map. You can train it on whatever you want. You can train it on disease detection. You can train it on, this is wheat lodging, so the difference between wheat standing straight up and wheat getting blown over. You can see it on weeds. Like, I'm really, really excited on finding differentiation on plants in fields using the Smart tool and then making prescription and then spraying it with an Agris.
And this is using Pix4D Fields. Is this something that is also available in other softwares, or is Fields kind of the go-to for this type of effort?
So the Smart tool is specific for Pix4D Fields, but if you're looking for the same type of analysis, you've got companies like Agramo that's doing it in the cloud. There's also Solvi, which is another tool, AgriScout, which is another one. I just put it on here. I know Nathan pretty well at Pix4D, and I've just kind of been blown away with some of the first data sets I've seen and how instant. This is at the field's edge doing this analysis, and you could have that prescription in an Agris in 30 minutes spraying just the corn plants. So it's pretty crazy.
Wild. Okay, deceased detection. So this is dead plants?
This is just potentially trying to find those dead plants or plants that are getting attacked by potential pests. So a lot of analysis is being run on the actual map. The orthomosaic is what we call it. But there's also the need of running an image analysis or running machine learning on the individual image. So companies like AgriScout will go and fly very low over the canopy and take a picture. And you can see on the screenshot there, the resolution is insane. It's like you're literally looking at the leaf, and then you can see if there's any sort of disease on the leaf, any sort of bugs. But what AgriScout is doing is just using the sonar on the bottom of the drone, along with some obstacle avoidance, and automating missions flying at less than 30 feet off the ground and taking it. And now that we have a 20 megapixel camera, instead of a 2 megapixel camera, we're getting imagery that looks like this and the spectral feedback to understand if there's any sort of issue going on. This is mainly just highlighting you're not always just doing the analysis on the entire map, but maybe just on the individual image.
And so do you basically, in a software like this, upload your hundreds of images and then it just filters through them all and kicks out data? Or are you selecting certain images that you want to have highlighted one by one?
It would be, you would upload all of the imagery and it would be able to analyze it all at once. It's not feasible at that altitude to stitch the entire map or model. So it's basically just taking photos and sampling. And you can see on the map, it gives you, each photo gives you a score. So you can see there's one red in their photo and a couple of the options are yellow. Those are photo locations where it came back with some sort of disease pressure.
Awesome. Okay. So now forest growth monitoring.
And I know we're running up against time, and we can click through the last couple of them fairly quickly. Just going to show, we aren't just talking about precision agriculture here. There's definitely use cases of buying a Mavic 3 multispectral for vegetation encroachment or vegetation analysis that's within the enterprise space or within forestry. So being able to fly over it and understanding the health of that forest, and then also doing a shoreline and understanding if there's any sort of, go ahead and click on the next slide there. I want to make sure we get to the questions. Just keep going.
Okay.
And then the last one there, being able to determine pollution rates with water. So flying shorelines there. Anything that has vegetation, we're going to be able to monitor it and understand how much is there and how much has changed over time.
So there's something about like algae blooms that you could do with multispectral. Is that a thing?
Yeah, I mean, algae blooms are putting off, they're reflecting light that's bouncing off the sun, and they're absorbing some and reflecting some of that back. We're measuring that reflectivity. And so if there's an algae bloom, you're probably going to see it on multispectral much faster than you'd see it with your naked eye or just a standard camera.
So I think that's the end of the content. Last question I'll have is that for multispectral, is there anything that's not plant related that's being used? I have heard like maybe finding plastics on shorelines or beaches that you can use multispectral data. I can't validate that myself, but do you see any other use cases that are not pertinent to living things?
There probably is. I mean, capturing bands of light very accurately, there's probably extra analysis that you could do. But if anyone has something out there that you've done that hasn't been vegetation oriented, but with multispectral, hit us up. I'd be very interested to know more. Perfect.
So that's, again, the end of the content. We're going to go into questions. I, again, want to point out that we did do this in collaboration with C.R. Kennedy in Australia, Copters in the UK. I'm in the US. And so if you do have questions, if you're looking to buy drones, if you want to follow up, there's email addresses to reach out to each individual company in each of their individual regions. We are here to help. So we just want to make sure that you have a place to go. Kyle is obviously from DJI and from the manufacturer, but we are, the next level deeper, looking over our respective territories and making sure that our customers are happy and that they know how to use the technology and they have places to purchase it. So reach out to us if you have any questions or any needs on that front. So now we will get into questions. We also have Kyle's email here and my email directly. So if you do have follow-up stuff, you can reach out to us. I'm going to pull up the question panel, which usually I would be looking at throughout the entire presentation, but I am at a hotel and cannot, I don't have all my screens. So let's just dive into a few of these in the little bit of time that we have. Let's see. Okay, price of a Mavic 3 multispectral. We never actually said that.
Yes. Is that something you want to cover, Randall, or do you want
me to? I actually don't know.
Yeah. Price, it's going to be very, very similar to the Mavic 3 Enterprise, like within $100, maybe two.
Oh, okay.
I don't remember what the price is, but very similar.
Yeah.
There's some difference on the camera side.
4,500, something like that.
Yep. But I would recommend if you're budgeting it in, include the RTK module. So yeah, maybe it's closer to the Mavic 3 No, it's less than the thermal price.
Okay, perfect. All right, so RTK we've covered, mechanical shutter we covered. There's a lot. I mean, you were very in depth, so there's not a lot of like questions. Someone asked about the calibration panel that you might recommend. Do you want to share that just in case?
Yeah. That's a tough question.
Is that a tricky one?
There's not very many people manufacturing them. I know that MicaSense manufactured them for the Red Edge sensor. They're still manufacturing the Red Edge sensor. That's now, I guess, an AgEagle product as well. Don't quote me that you should go to AgEagle or go to MicaSense to purchase a calibration panel. I'm not sure if they're selling them individually. It's a great panel. It works with the Mavic 3 multispectral. I know of that. It's just, they may be much harder to come by, but there's also methods of being able to make your own with the right materials. So we can maybe send up follow-up.
Perfect. That's fine. Someone asked about infrared sensing as like an additional band, and I know that MicaSense made the Altum and they added thermal in there. Is that something that you found to be beneficial for picking up invasive species or anything like that? What is your opinion on infrared in the whole multispectral stack for ag?
There can be value there. We've seen a lot of people go after thermal for water management and water stress, but beyond that, it can add extra complexity. This cost of sensors is really expensive. And remember, you're typically flying over very homogeneous areas, meaning large cornfields, large soybean fields. So stitching 640 by 512 resolution imagery of cornfields is really hard to do. Within plots, there may be value there, but I would stick to multispectral. You're going to learn more on vegetation within those bands.
Okay, I'm going to ask one more question, and I apologize, guys. I have a flight, so I can't go too much beyond, and I know, Kyle, you've always been willing to do that, but we will go through your questions, and I'll send out an email to everyone that registered with the answers to the questions that we could dig up. There's quite a bit, and I appreciate you guys being so attentive and also so curious, but it's an IOU for sure. I do want to say that the recording from the webinar will be sent to you within the next 24 hours. If you want to revisit it, if you want to share it with other people, that's appreciated. I've mentioned several times that DJI Terra 3-month license, that is just for you joining this webinar and filling out a short survey so that we know who's actually interested from this webinar. So I've sent that link again in the chat. If you go through, fill out that 2-minute survey, we'll make sure that you have that license soon. I can say it's working with DJI to get those licenses sent out, but I will say that it's within a few days at the most. So again, thank you for being here. Thank you for asking all these questions, and thank you for making Kyle and I's life easy by you coming to us with wanting to learn more, because that's what we are here to do. So my last question is on sample data. There are people that they're maybe going to get a license for Terra through this webinar, or they're just curious about how this might be different than what they're capturing already. Does DJI provide any data sets or something that they can use for processing that is readily available?
Great question. The only data set I have that's publicly shareable, ready available, is of Iowa in December. So not ideal, but you can still have access. Hit me up via email. And we can also, I'll follow up with you, Randall, so that you can send it out in the follow-up. But we are trying to figure out data repository and where we can house a multispectral data set. So I'll follow up.
Sounds good. And again, there's literally there's probably 30 to 40 more, well, probably 40 to 50 more questions that we didn't get to, and some might be repeated. I owe you answers, me personally. I will likely tap Kyle to help me with some of those answers, but know that we'll get back to those questions because they are important. We just didn't have the time to get to them. Kyle, again, thank you for your time and your expertise and your passion for this technology. Everybody that spent part of their day with us, thanks for being here. And you'll see the recording soon. If you have any follow-up questions, hit either of us up via email, and we'll do this again soon. Take care,
Thanks, everyone.